in your body, we have three types of things. We have three types of things that are called genes. These are genes that are actually responsible for cancer and cell development and growth. Number one, we have something that is called proto-oncogenes. Now, when you hear the word onco, know that is cancer. So if you hear oncogenes, know they are genes that actually cause cancer. So we have proto-oncogenes. Now, these are genes that regulate normal cell growth. But the proto-oncogenes, from the word proto, they cannot cause the cancer. So they're the ones that actually regulate normal cell growth. However, remove the word proto, you remain with oncogenes. Those are cancer causing. Now, what causes the removal or the drop of that name proto? Diets, 85%, cigarette smoking, alcohol, medications, inflammation. All these are going to actually cause mutations that will actually convert these proto-oncogenes into active oncogenes. That is cancer. So mutations turn proto-oncogenes into the overreacting form of the same proto-oncogenes that is actually called now oncogenes. So we move from proto to the oncogenes, now we have cancer. That tells you all of us, we have abilities to have the cancer genes. We have the ability. We all have proto-oncogenes. But now, us converting the proto-oncogenes to active oncogenes is where the difference comes in. This is where the people who are fasting actually survive, because they produce new stem cells that give them new proto-oncogenes and their system is stabilized. This is when you drop the inflammatory foods, your proto-oncogenes will remain to be proto-oncogenes and they will not overreact into oncogenes. Does your doctor know that? Amazing. Number two, we have something that is called tumor suppressor genes. And understand the word tumor suppressor genes. We said tumors, benign, malignant. So tumor suppressor genes, their role is to suppress the growing tumors. So your body is designed perfectly to actually help you recover, if at all your system is misbehaving. So you must support it. Good. So tumor suppressor genes, their role is to actually maintain or actually suppress the overreacting or the growing tumors. So this is part of actually immune system. And also the another role is to actually trigger cell death. So they trigger apoptosis. You remember? They trigger natural cell death. That tells you if there are cells that are actually overreacting, they'll be shown, hey, you know what? Please, it's time for you to die. And then they die, and now cancer disappears. So therefore, we have abilities to actually have cancer, but our system is designed perfectly to actually protect us from that. Number three, we have something that is called DNA repair genes. The DNA repair genes, from just the name DNA repair, what they do is they come and destroy those genes or that DNA that is actually mutated, that is actually causing you problems. Because remember, when the DNA is messed up, now we cannot regulate the cells through the cell cycle. So they evade the cell cycle, and now we've lowered our immune system because we don't have even the tumor suppressor genes, because they're overwhelmed with inflammation, sugars, seed oils, and wheat products. You've lowered the immune system. The tumor suppressor cells are going down. Now you have these cells that are rapidly multiplying because they are turning from proto-oncogenes to oncogenes. Now you activate the rapid multiplication of cells and division of cells. You are in trouble. You are in trouble because the DNA repair genes, their role is to actually instruct the destruction of the already mutated genes that are causing problems. So you see, your body is totally so safe. This body is designed perfectly. There's nothing from outside that can actually fix your internal world. Imagine that. So you have proto-oncogenes, you have tumor suppressor genes, and then you have the DNA repair genes. All of them working in your favor. So now, what is the difference between your cells and the cancer cells? Because you will wonder, where is this cancer coming from? What are these cancer cells? We've said it's a group of conditions, so we can't even go into much details about that, but we can actually tell you the difference between a cancer cell and a normal cell. Of course, the mutations are there, right? Of course, the abnormal multiplication is there. You can easily know that. But what is the difference between cancer cells and the normal cells? Number one, uncontrolled proliferation. The word proliferation is just an English word, a big word to confuse you. It basically means multiplication. So because they are evading the cell cycle, they are evading mechanisms that control their division and their growth, they will multiply abnormally. That is what we call controlled proliferation. And as they multiply abnormally, they're actually doing that for them to survive. They know if they don't multiply rapidly, the immune system will destroy them. So they are doing that intentionally to actually make sure that the immune system is unable to destroy them. And if it does, it will still leave others multiplying rapidly and they will be spreading. So the immune system will be overwhelmed. Now it'll give up. Number 2, they are resistant to cell death, apoptosis. So they evade mechanisms for even the tumor suppressor genes. They evade that mechanism. Therefore, they cannot die. Other cells have to reach a point, they are mature, they have to die, so that we get new cells from the new stem cells. And this is where fasting comes in handy, because fasting helps you produce new stem cells. And now you have new cells. Now you have new genes. You have new DNA being restored every time. So fasting is very important. So as you complain and you say, oh, you know what, if I fast, I will die. Okay, wait, you will die for not fasting actually. You will die and we will celebrate you. We will say, oh, you know what, death will one day die just because you did not fast. So start fasting. Even a 24-hour fast, even a 16-8 is a fast. Just have discipline for diets. Number 3, there's something called angiogenesis. And again, that's a very huge term. You're like, angiogenesis, daktari, angiogenesis. Angiogenesis means that you see cancer cells are special in a way that they can actually make their own blood vessels to supply them with nutrients and oxygen. So even if you try to block their supply, like for example a tumor, you try to block supply of oxygen and nutrients, it will form its own blood cells and tap into your blood system to actually get the nutrients and oxygen. And remember, these cells are rapidly multiplying, but one thing that you should know, cancer cells don't like oxygen. So they pick a very small amount of oxygen to utilize it, but they need nutrients more. So they like a place where there's low oxygen levels. And this tells you, for you who don't even do a morning run, to actually activate your lungs to give you more oxygen, problems. For you who constantly consume sugars that hold on to the red blood cells, therefore there's no adequate supply of oxygen in the system, because red blood cells are the ones that supply oxygen throughout the system, problems. So sugar is becoming another problem here because it limits supply of oxygen to tissues. So angiogenesis. So cancer cells are so good that they will actually make their own blood cells. But this is a concept that happens all over our bodies, our brains. So before you get a stroke, you've actually fed yourself so adequately to get a stroke. Because if the blood vessels that supply the brain start to block, the brain has a way of just forming new blood vessels that will actually they will skip the other blocked blood vessels, and you have supply of oxygen to the brain. So before it dies, you've actually done a good job. You've actually ate yourself that sugar. And no wonder some of these conditions are considered diseases for the elderly. The same happens to the heart. If the coronary blood vessels are blocking, the heart has to form a way through angiogenesis to give you new blood vessels to supply the same heart muscle. So by the time you're getting a heart attack, you've worked so hard in your kitchen. Oh, mekula, my friend. Number 4, we have inversion and metastasis. Now remember when you said about malignant, sindio? Which tusema side moja ni benign, side ingine ni malignant. The malignant tukasema they are divided into 2 according to the places that they spread through. One is through blood, we call them the sarcomas, and one is through the lymph, we call them, we call them what? Iko mtu uko backbench amelala. So that spread is what we call metastasis. Metastasis. So cancer is metastatic, means it moves from one tissue or one organ towards the other to destroy it. And it moves through 2 things. One is through the blood and one is through the lymphatic system. So inversion and metastasis, which means cancer cells, unlike other cells, the normal cells, they will not spread to other tissues. They will differentiate and do their work as planned. They will go to the eye, they'll differentiate into a foot or something else. But the cancer cells, they don't differentiate in that manner. What they do is just they multiply rapidly and then they spread, and their intention is to actually, and the cancer is very stupid because it goes and spreads into the organs to destroy the same organs, and it still wants to survive. So when you die, cancer dies. So is it not a stupid mechanism anyway? But anyway, that's another day story. Number 5, cancer cells are so prone to avoiding or evading your immune system and mechanisms. So one, they avoid the cellular mechanisms, the cell cycle regulation mechanisms, that is uncontrolled proliferation. And then now after, they have to actually avoid or evade the tumor suppressor genes and the immune system that actually suppresses them and destroys them. So they are so clear. That's why they are multiplying rapidly to overwhelm the immune system. And the last one, they have multiple DNAs. They keep on mutating every single time so that they can actually continuously evade the immune system. And that is what we call genomic instability. So 5 characteristics of cancer cells for the students. Oh, if you do this, you're good to go. Because this is a question that you'll expect. 1, uncontrolled multiplication or proliferation. Number 2, resistance to cell death. Number 3, angiogenesis. Number 4, inversion and metastasis. Number 5, evasion of the immune system. And number 6, genomic instability. Have I not explained it in the best way possible?